My name is Vijay Samuel, and I'm a principal architect at eBay for the reliability engineering group. I've been with eBay for almost 13 years now.
I'm Sandeep, and I'm the lead software engineer of the reliability of the observability platform at eBay. I've been with eBay for 12 years now.
And we're going to talk about a concept called AI explainers, which we have been working on for the last little over a year now, I should say, and how we envision it to be useful for triage. This is a concept that we introduced during Kubecon London as part of one of the opening keynotes, and this talk will be an extension to what we talked about during the keynote and where we see it going. So we'll talk about what the problem is, how can we solve, talk about a few explainers, some examples, and then where we see it going from this point on. So let's open up by saying that observability is hard, and with the number of microservices that are growing, observing becomes even more complex. We have a ton of data. The call chains become more and more complex. To give an example, some of our APIs make hundreds of database calls, span over 100 microservices that they call over the call chain, and knowing where they fail, observing all of that manually can become very tedious. There are a lot of teams that are involved in these activities, so if there is a breakage in the call chain somewhere, which team do you involve? Is it the right team? If it's the wrong team, you're wasting more time. And every failed opportunity to diagnose the issue is a lost customer experience. So time spent in triage and restore, there is yet another customer whom we have failed to keep our promise, which is to provide the best customer experience possible. So what can we do? Today, for everything, the standard answer is, let's use AI. Okay, let's say we do want to use AI. How do we make it work? How do we do it effectively? And what are the key areas that we can solve that offers the biggest bang for the buck? That said, using AI as is has its own challenges. And the first time, like many of us, when we got our hands on AI tools like ChatGPT, it would be we just assumed that we could solve everything. It's like, just go and rewrite this for me, and our hope is that it will magically happen. But reality can be very different. So one of the first things that we do is, like, we forget what we are all good at. We are good at engineering, and when AI comes in, we just think that, okay, engineering is no longer required. Prompting is everything, and as long as I'm able to prompt, I'm able to get everything. But that is rarely true. We bite off way more than what we can chew. Just in one prompt, we want a full rewrite of something. That also does not really work. Hallucinations. Once we go down the wrong path, we basically assume that, okay, I can make this right by reprompting, but that spins off of control even further. And finally, we forget what we are building for. Just because AI is there, we try to do cool things, but the cool thing doesn't necessarily have to be a reflection of the product that we are trying to build, which is observability. So when folks were trying to solve so many things of massive complexity, one of the things that I personally was advocating for within the organization is, why cannot we do the simple stuff? Why cannot we explain? And this, while using things like ChatGPT, was very evident. If you give it a few hints, it can blow up the hint into something that is more tangible. So LLMs are good with text. And the other thing that folks were trying to do a lot is, okay, I will give everything to the LLM, and then the LLM will do magic. But on the other hand, with years of observability practice within the industry, like, we have seen that there are certain things that can still be done programmatically. So given a time series, finding what is the min, max, 99th percentile, and whatnot, you can still do programmatically. Or if it is a trace, there is a programmatic way in which you can find what is the critical path. You don't need the LLM to figure that part out for you. You can do that through simple engineering. And the other one is like, how can we tip the probability in our favor? Again, programmatically doing something is predictable. There is no probabilities of what the LLM might do at that point. You are not leaving it to chance of the quality of your prompt. And if there is less randomness, lesser involvement of the LLM in some of these things, the higher the chance of you getting better results. And the other thing was, instead of trying to shove everything into the LLM, generate summaries for smaller things and then give the summaries, because that might occupy lesser context window. So that said, we basically started building explainers, and the first one that we basically built was a trace explainer. Given a trace, tell me everything I need to know about the end-to-end call chain. Where was the most time spent? If there were errors, where were they? And then how did it impact the execution? So very basic questions that we are trying to answer from get answered from the trace, because that funnels the problem down into a very small sample space. If you have 100 microservices involved, and if you are able to say that this is the exact microservice and this is the exact span within the microservice that impacted this given call, that saves a lot of time. So what did we end up doing? We first cleaned the data. One of the things that we constantly run into as a problem inside of eBay is that, given that we have thousands of microservices involved, the size of the trace itself is pretty large. A single trace can have 8,000 spans, and that can basically roughly translate to few megabytes of JSON when you bring it back. And just giving it to the LLM can be futile, because like I don't think there is any LLM that can take in 16 MB worth of context in one shot today. So what we ended up doing is we started reducing the number of spans that were involved. Anything that was of low consequence, clean it out first so that you have a smaller subset. And you can even do removing unnecessary attributes as well, because a lot of attributes are repetitive and not of high consequence. The next, we basically did few shot prompting. There is always some knowledge that is primitive to how your organization operates, where 4xx might not be consequential, but 5xx is something that you need to pay attention. So those, if you prompt, you can basically avoid the LLM going off into tailspin by paying attention to things that it doesn't necessarily need to. Keep focused on self-time, because self-time will ensure that you're spending time on spans that are actually occupying a lot of CPU cycles. And then take small chunks of the call chain, the reduced call chain, and then keep summarizing them. That way, as you take those summaries and then do logical reasoning on top of it, then you basically get better responses. Yeah, so simple reasoning, and then we basically only consider the critical path. So the trace can fork off into several paths, but there are only one or two paths that are actually consequential. So how do you only pay attention to that? Similarly, we did a logs explainer, which given a set of logs, tell me useful things about them. And here also you can do stuff like grep for certain patterns and only evaluate those patterns, only look at 1,000 lines of logs or 10,000 lines of logs, depending on how much context you want to give. You can also do take chunks of logs over time, keep summarizing them, and then look at the aggregate summary, and then do reasoning on top of that. The next one that we also built was a CLI explainer. Given a certain CLI command and a way in which you can interpret the CLI command, do some reasoning on top top of it to know if something is healthy or not. So take kubectl logs, kubectl describe, kubectl what are the other ones that are there? Kubectl get pod, get deployment. Make sure that every command has a certain particular field of interest set in a certain way, and make sure that all of them check off the box, and use reasoning to make sure that the check passes. And finally, the one that I am personally very interested in is basically a metric explainer. Most of our triage process takes into account a handful of time series that we basically look at to see if behavior is in line to what is expected or not. So explain to me the trends, are there any anomalies, and if there are any anomalies, do the anomalies persist? So yeah, so check for anomalies. So we already have an anomaly detection platform inside the company that can basically look at arbitrary time series and then say that for this particular fixed time window, was there any anomalous behavior or not? Reduce the noise. So a lot of times what we see, anomalies can come and go. There might be a big spike and then it tapered down on its own. Some of that can be programmatically eliminated without having the LLM figure out is this anomaly consequential or not, because all those anomalies that cleared out on their own are going to unnecessarily occupy space on the context window. Reason if the anomaly is sustained. So for anomalies that are closer to the current time window or the last 5 minutes, last 10 minutes, those alone hand off to the LLM to decide, okay, is this anomaly sustained? And then summarize all of this. So there are key statistics like min, max, average, anomalies that are resolved, current anomalies. Take all of these, give them as input to the LLM, and then finally get a summary of what was there. So this is an example for that. So the last but one spike is not really of any consequence because it resolved itself. The only one that we really need to ask the question, should I be worried or not, is if there is one that keeps sustaining itself. So how was all of this useful? We have a few examples in which Sandeep will go over to see what we have learned so far.
Thank you, Vijay, for the walkthrough. Yeah, as Vijay mentioned, in the next couple of slides, we'll see how we are using these explainers, which will bring in the real value for us with the real production applications. The first slide here is for the trace explainer. The right side, what you see is how our trace explainer looks like. It's basically a real trace for a real production service. And instead of scrolling through hundreds of thousands of spans, you can see a very clear human readable description on what actually happened with this particular trace. And also it gives information on which span is the problematic span potentially. And also it gives the information on the critical path. We programmatically figure out the critical path, and so potentially we can figure out the root cause here. So let's look at each of these sections. The first section in this particular example mentions that the problematic span is the monster service / get call basically, which took about 46 milliseconds, and it contributed to more than 50% of the overall trace time. It even explains that, I mean, if we go into the further details, it even explains that, it's all the internal processing data. There are no child processing happening within that particular span. So it's all self-time of that particular span. Right? It also makes a call to a particular database, and it also gives the information on what namespace within the database it's looking at. So all these are very critical information, right, for us to debug and figure out the root cause on where things are wrong instead of scanning manually through the spans. And here we also can see the critical path listed in the bottom, and it can see how it is affecting the upstream pools. And obviously, if latency is what we are chasing, we know that targeting this particular span or this particular service is the main thing what we should be doing. And here, this particular trace doesn't have any errors. If not, we would be seeing even the explanation for the errors and also the critical path of the error itself. Going to the next slide, this talks about the metric explainer. It gives an example. This is how our metrics explainer looks like, and on a normal without this explainer, what we would have done is to go to a dashboard, where we have built the panels and we look at all the panels and we analyze where the issue is, and we'll take it from there, right? But with the beauty of this metric explainer it does automatically for us. We have identified the golden signals for us, which is basically the error, latency, CPU, memory, GC, and so our explainer basically looks at the data for all of these signals, and it kind of summarizes. It eliminates some of the noises. Example, this is something which Vijay mentioned as well. In between there is a big spike. It is programmatically discarded because it's already been resolved. But yeah, we are mostly interested in the issue which is happening right now, and basically it also points out which region the issue is happening at. In this particular use case, the issue is happening at LVS region internally, and it also mentions that the other two regions, which is the Reno and SLC, doesn't have the same issue. So we kind of know that where to look at. Right, so that's a main advantage of that. No more looking at manually at the dashboards. The explainer kind of helps us to understand what is going wrong and where. The next one is the CLI explainer. The CLI explainer, it takes basically input as any CLI command. We don't really need to manually execute the CLI commands anymore. We can, of course, but the problem is, to parse the information. Some of the information could be a lot. Example, if you try to get events from Kubernetes, particular pods or any of the namespaces, right? It could be a pretty large, and it may consume time to parse manually and try to understand the information. So the way the CLI explainer is built is, you can give the kubectl command, and also you can give some standard prompts on what you're looking at. Example, you may be trying to find the pods which have restarted couple of times in the last 1 hour, or any of the prompt can say all the details what's needed, and also give the kubectl command. It will run the kubectl command programmatically. We parse the information from the output and we pass it to LLM to do the analysis. In this particular example, we can see that for the 4 pods we were interested in, it kind of gave the information on where it's running and what CPU configuration it has, memory configuration it has, and it also mentions that there has been no restarts. So it kind of brands it as healthy, and it also has a to-do list on what all things it did. So it looked at the logs and looked at the health of the pod, and it updated it gave the result saying it's healthy. And one thing to add here is basically this was built probably like a year ago. Back then, the MCP was not really a thing, but with MCP, things could change. I mean, definitely this would change. We don't need a custom solution like what we have built. It could be like a MCP, which is calling a CLI tool with a custom prompt that would solve the problem. Having said that, I'll hand it over to Vijay, who will talk a little bit more on what's next.
Thank you, Sandeep. So I think in KubeCon London, we introduced some of this, and since then we have been building a few things. But one of the things that I mentioned during that talk is things that we build today are irrelevant tomorrow. That's how fast AI is moving. And I think as MCP keeps shaping up, how we approach this problem is changing a bit, but some of the core fundamentals remain the same. So probably next KubeCon, if we have the good fortune of being able to talk about this more, it would be all centered around how we are using MCPs. But the focus should always be on building the foundational capabilities, being able to query data from the observability platform and allow MCP clients to have access to it. That's the foundational capability that's there. And how can you do it in a way that you are minimizing the amount of context that you're occupying? So if you are using Prometheus and you have an MCP tool that is querying Prometheus, just returning raw JSON is of very little consequence. If you're trying to trend something that's over a year, that one query is enough to blow out your context window, and you will not be able to make more complex analysis. So how can you represent the data in such a way that you're occupying as minimum of context window space so that you can give in as many queries worth of data to do some amount of reasoning. So, and you need to be able to do that for every signal. How do I do it for trace? How do I do it for logs, CLI invocations, and whatnot? Standardization. As I mentioned during the panel that happened a couple of hours ago, standardization is key. And this basically allows us to do things like have one workflow that mimics an SOP of a human triage, represent that as tool invocations and summarizations, and be able to reason on top of that. So a lot of effort has gone inside the organization to make sure that we have standard golden metrics that's there across all microservices that are there, standard trace instrumentation. That way, with one particular way of triage, we should be able to use a mix of a good MCP client, MCP server, a telemetry or observability MCP server, and be able to do a lot of things using that. Come up with a lot of prompts. The more that we have purpose-driven prompts to be able to do things, the better. While discovery-based triage might be the coolest thing that you can come up with, it is not really the most practical thing that you can do in real life. As long as we have standard prompts to say that, okay, identify slow traces. How do I identify a slow trace? First query for span service.name equal to foo, duration greater than 20 seconds, pull some traces, pull the slowest ones, do some evaluation on top of it, and then come up with a report. That is a prompt in itself. Find consequential errors. So how many of these building block prompts that we can come up with so that we can layer them later? And for each one of these, try to explain. Returning JSON is a very low consequence. And once you have all these prompts, explanations, you should be able to create workflows out of them. As an SRE would triage, do step 1, do step 2, do step 3, along each way, summarize, reason on top of each summary, and then finally come up with a final reasoning. And automate away, like start with small things. We have a goal to see if we can have cardinality rate limit, which is a support ticket today. How can you automate that entire process in such a way a person need not execute it? For that, there is some preliminary analysis that needs to be done, saying that check why is the cardinality rate limit being hit? Is it okay to bump them up? If it is okay to bump them up, by how much should we bump them up? So all of those can be automated through crafty prompts, and a workflow can be done to do the actual execution. So the amount of opportunities that we have is infinite, but the core principle always comes to focus on how to keep the context window minimal, use algorithms and programmatic ways as much as possible to do most of this work, and then use LLMs to their advantage, to their strengths. So that being said, we'll take some questions. Sure.
Should I just pick it up?
Is it okay to just speak out, or?
Okay.
Yeah, I can repeat the question.
Okay.
Yeah.
So you and I had the conversation earlier.
Yeah.
Basically, how much of this work, we're talking about how the tools should be more usable also for a human, not just for the internet. How much of this work overlaps what you do for runbooks and for SRE triage?
There is a significant overlap in the sense that at least we have. The question is between runbooks and SREs, how much of the work that we are doing has an overlap? There is a significant overlap because, like, we strongly believe that anything that an SRE is able to do as a human, that is the first thing that we should try to create a runbook or automate it using some of these MCP clients and MCP servers that we have. Because if someone is not able to do it, then what is the point in automating it? Yes.
So you showed a great summary where you said, here's the critical path.
Uh-huh.
If you have spans that are many chains long, how did you decide from the erroneous span, what were the successor, what were the predecessors? Because there could be many irrelevant ones in the chain. How did you do the LLM to just show them?
So basically, for latency, we go for the longest call chain that is there. And when we eliminate redundant spans, we never eliminate from the call chain, and we are from the longest call chain. We remove attributes. Even if we do end up removing, we make sure that we are stitching it back into the correct parent so that the integrity of the trace is never compromised.
But like they could, for a human summary, they could be like really fat. So like, did you reduce down the number of spans?
Yeah. We always try to reduce the number of spans to what may be consequential. Like we know that there are certain spans that are called by thread pool invocations and whatnot. So those can be in the hundreds that we just eliminate. Yes.
Thank you. You were talking about triage problems. Have you think about already mitigating or solving them using also AI?
That's a good question. We want to get comfortable with triage first, because triage, as most of you know, does not involve any mutations. And we have read so many interesting LinkedIn posts on how mutations have wrecked company databases and whatnot. So eventually we will get there. But first, master triage is where we are at right now. But that's a good question. Thank you. Yes.
Yeah, sorry. I have 2 questions, if that's all right.
Sure.
Number one, how do you feel like, or do you feel like having access to more of like an agentic kind of form of SRE with sufficient low-level data that like you guys are able to build workflows for? Do you feel like that denigrates the value of the existing observability stack of companies like Datadog and more dashboard-based systems, since like you can kind of now chat with it and like based on a runbook that you've established?
I have not used any of the vendors out there, so I cannot really comment. Like as I said, I've been with eBay for 13 years, and like through the 13 years, like it's been homegrown for the most part using open source projects. So unfortunately, I cannot give a straight answer on that one.
Okay, awesome. I forgot my second question, but that's okay. Thank you.
All right. Any more questions? We are happy to answer. I was told that we are out of time, but like I can answer. Yeah.
Approximately what percentage of your alerts are being triaged successfully by your explainers?
So right now we are using it only for manual triage. We don't have the part where it's like, okay, you have alert manager send a trigger and then it auto triages. For certain flows we have, like for SLO violations, we have it posting into Slack saying that, okay, click here and you will get the explanation, and then there is an explanation that's there for why the SLO failed.
Overall, would you call this experiment successful within your team?
Oh yeah, for Trace Explainer especially, like it's a massive success. Like we have so many use cases where people have been able to sieve through very complex traces and nail down to the very particular issue that caused the incident.
Nice. Thank you very much.
Sure. Thank you. All right. Thank you, everyone.